Welcome to another episode where we delve into geodesy and distinguish geodesies in the world. My name is Mehdi Ishaq, and today we have the privilege of sitting down with Professor Juergen Mueller from Leibniz University of Hannover in Germany. Professor Mueller has great contributions to physical geodesy, relativistic geodesy, gravimetry, and lunar laser ranging. Please join us as we delve into his career, insight, and how his research has affected our knowledge in the field. Thank you very
Okay.
much, Professor Muller, that you accepted my invitation to this interview.
Yeah, thank you for inviting me and giving me the opportunity to a little bit advertise Geodesy and that may people aware of what the nice things in Geodesy are.
Thank you very much. Jürgen, I know you around 20 years at least,
Yeah.
at least 20 years. So you have done a lot. And when I got to know you, you were already professor. It means that you have had a long journey in this subject. Please tell us and the audiences what was the key motivation that kept you active in this subject? How did how are you attracted to this from the beginning? Please tell us all your journey.
Yeah, maybe say as the real key was one of my professors, Professor Manfred Schneider at the Technical University of Munich, who gave courses in celestial mechanics and relativity, and I liked it very much. But my first contact to surveying was much earlier. From my grandfather, I had a leveling device at home. Then you may know the book The Castle of Kafka, where a land surveyor plays a major role, not only a fortunate role, but he plays a role. And so I got into contact at these levels. And also during my military service, I was at a surveying group, and surveying at the military service was a nice thing because you could do different things, and so I learned a little bit the practical surveying. But as I said, the real fun came with my study at the Technical University of Munich in the 80s. And I got interested in relativity and collaboration with physics. Another teacher there was Professor Siegel, also very famous. So I learned a lot. And then after finishing my study, I got a PhD position with Professor Schneider on the analysis of lunar laser ranging data, running relativity tests, and it was really great. Later, when I finished it, I had a postdoc position where I worked with Rainer Rummel, with gravity field studies, and with the GOCE. It was a preparation of the GOCE mission, and so I swept. I did my second degree. Is called habilitation in German. I don't know if it says an English word or similar word. And I did some studies in GOCE, and so I was in the business. So really great.
Thank you very much. Very interesting. Very interesting. So, Jürgen, you have done this long journey. You have managed this journey for a long time. Have you seen any change or any specific challenge during this journey?
Yeah. There have been many changes. When I started, we did not have personal computers, almost nothing in coding, just started learning. There was no GIS in the education. GIS, Geographic Information Systems, no GNSS. It came afterwards, and we learned it later. So many changes. And also in my field, I'm now working with gravity field missions. Also, they have not been there. Just 20 years ago, so we had the first launches of CHAMP and GRACE and GOCE then, and many new things. And I had to learn also to change not to change my interest, but to educate myself to keep speed with all these things. All these collaborations have been extended. For example, many interdisciplinary activities with the satellite missions, but also right now and starting already during my Munich time, collaboration with the physicists, because I have new concepts, own concepts, which can be used. Maybe I can mention quantum technology, optical clocks, which can be used for height system measurements, or quantum technology as accelerometers. So many new ideas that we can now further develop. So there have been, I think, more changes than what has been kept. And maybe another interesting thing is also that when I started, there was not so much demands to publish papers all the time, and this increased and increased, and now many quite often only the published papers and age index are looked at, but not your real work. So it's also funny. But so you see many changes, but this also keeps it interesting because so the whole field of geodesy, because we have so many contacts and so many ideas and working fields. Yeah.
Thank you. Yes, I do agree. It is numbers. Nobody can actually evaluate any person by numbers. I
Yeah.
think this guy, Ed Fush is a now
Yeah.
guy we know, and he made a revolution actually in gravimetry. He had only 18 publications
Yeah.
during his career life. So, but he made a revolution.
Yeah.
So we hope that contribution actually is the main one. I do agree with you, not the numbers, not the
Yeah.
numbers. Yeah, exactly, exactly. You can still, when I am in the society, when I talk to people, and they ask me, "What are you doing?" I said, "I'm geodesist." What? Geophysics? No, geodesy. Oh, geology? No, this is just no. It's not that. How can we do that? So what can we do that the society can get to know the subject?
Yeah,
What do you
I
think
think,
about it?
yeah, I'm faced with the same problem. And then when I start explaining, sometimes I mention, for example, mobile phones, that all, so the positioning that people use for navigation, the maps, everything is related to geodesy. So the background, the backbone are reference systems, global reference systems, that we need techniques, the satellites to keep it running. But it's only one part. Another part is we have this gravity satellite missions where we observe not only gravity but satellite missions where we observe, for example, sea level rise, ice melting, all these processes of which are related to climate change. So the geodesy contributes a lot to provide data for better understanding of climate change processes. And you may know, or even the IPCC reports, the geodetic techniques are mentioned because they provide so unique data of change processes, which can help to better quantify what's going on and to achieve a better understanding how the processes run of climate change, global change, and that maybe one can do anything against it at a certain level if I know what is happening where. But it's a long story. So I think geodesy is relevant at various levels, but to make people aware is another story. That I know it. Yeah, well.
I do agree. So when we stop our services, they will realize.
Yeah.
When they stop functioning, then we realize that what they are missing. So when I talk to people, some of them, was one of them actually asked me, "What are you doing?" I said, "We are making shape the size of the Earth." Oh, we already
Yeah.
know that. Okay, you already know. So some of the geodesists made it actually. You already know that. So they think that everything is done. Yes, please.
Let me add, because so lately I had some discussion on Earth rotation. So many people do not know that Earth's rotation is changing all the time, and then what are leap seconds, and days are getting longer or shorter, and it's then they're really interested if you start explaining. Oh, and this is all geodesy, and you need some surveying and techniques to monitor it, and then it's people become interested if you have nice examples. And with ice melting sea level, you have anyway good examples. So we will see.
Still, we have to explain a lot so that the
Yeah.
people can understand.
Yeah.
The good ones, they know the subject. They just, when we say geodesy, they just imagine a
Yeah,
total station or GPS at most.
yeah,
And when we say that it's not geodesy, we understand what else is it then? So
yeah,
we have to start explaining about
yeah,
physical geodesy, climate, and
yeah,
our
yeah, that's
connections.
true.
Yeah, yeah, I know. So, Jürgen, how do you see the subject in 10 to 20 years later, based on this
Yeah.
trend that you have observed
Mhm.
and experienced?
Yeah, I think certainly also quantum technology will play a much bigger role, and not only for satellite missions. For example, you can use quantum gyroscope, quantum accelerometers, which you can use in navigation systems. If it's getting more robust, also the use of optical clocks for height systems, for new kind of reference systems may play a role. And you have seen artificial intelligence will certainly play a big role. It is not so unknown as it seems to us, because some pattern recognition in the field of photogrammetry is a very old subject, but maybe now you may have the computer facilities and you can apply it for many more things. So this will certainly be also will certainly be relevant and change our way of working in geodesy. This AI techniques, the quantum technology, I think, and in 10 years, I think new things may come where we will, which we do not know right now. I think it's certainly needed to have even better interdisciplinary, transdisciplinary collaboration, because there are complex challenges with this global change, but also at various levels. And I think only this good collaboration and is what gets us the next step.
Thank you.
Yep.
This was interesting. Yeah,
Yeah,
yeah, that's it. I do agree. So, if it, especially this artificial intelligence is actually dominating everything. So one thing that I see in artificial intelligence is that people have started to applying is we don't understanding it. That's a little bit dangerous. That is
yeah,
dangerous.
but it's more or less that they have a lot of data and using some probability methods to find out of this data certain patterns. And this is then your solution. You have not as direct deterministic connections. This is a poor thing, but there are certainly examples where you can very well use it. And maybe at the end, it's a mixture. I said for some application, you should use it. And anyway, you cannot avoid it right now. Even at the teaching level, students use it. And many people use it. But you should be aware of what you are doing. And this is really only not a deterministic approach, but a probabilistic approach. And but I'm not against it. So we should make benefit of it. But how it could be done best, I do not know. We will see. This will develop. We ask for the next 10, 20 years, then we
Exactly.
will see
That
it.
was yeah. That was exactly what I meant. It is so. It is so. And what do you think? What is our role as a geodesist? So to make geodesy more now for decision makers, the people they are sitting and governing some institutes or the country generally, the
Yeah.
management, they understand the value of geodesy. What can we do?
I think if you talk to people, politicians, you should first find or take simple examples, maybe of their region. So, for example, if people live in the Pacific, then sea level rise may be a problem. If they live in an earthquake region, then maybe deformation measurements or maybe some precursor events may play a role. So you should talk to people and then find examples where they can really benefit from our geodetic means, reference frames. I think normally it's self-explaining, because all the maps and everything you need is geodesy. But maybe you should then also invite politicians or organize events for them to explain them at a certain level. what's going on. So for example, if you have got a new project with this quantum technology, and then I can also not only use it to explain how we can use it at all, but also I can promote geodesies, that height systems is needed if you want physical heights, if you want to have pipelines, water pipelines, or that's really relevant. And also, even if you have the fast trains, you need to know where they go, tunnels, and there are many examples, and so you should select those examples and then explain them. Maybe you should also invite politicians to your labs. Should have public events. And this is also what we are running, is that we have, on one hand, show our research, what we are doing here, and how it's related to some yeah uh, some public issues, as I can repeat, sea level change, but also you have ice melting. You have all these changes in the hydrological budget. So you can find good examples, and then you have to find some level of conversation with the politicians, with the decision makers, and you should also use this social media. Maybe make videos. I think on the GEOS portals they are very active and very successful, having nice videos and simple explanations of the various things. And this should be done so that people see how it works and can easily understand it. Yeah, but it's a multi-level approach how to achieve it, and maybe you to make it aware, you should also start in schools. So what we are missing right now is a sufficient number of bachelor and master students, and that means when students come from school, they should be earlier be aware what the nice things and the relevance of geodesy is. So we should start at schools, maybe invite school classes to our fields, have maybe joint projects, advertise in schools. So, as I said, at various levels, you have to promote geodesy.
Yes, yes, I do agree. I like very much this school
Yeah,
activity,
yeah,
actually.
yeah,
I think we have had actually this program at my university, and that I
yeah.
was active there. We went to schools, but it was our
Mm,
attracting students for the program, but was at high school level. We should go
mm.
lower. We go over and but
Yeah.
yeah, very basic, so they get to know that subject. Thank you very much. So, Mugen, as the last question, what is your advice to younger generations, younger geodesists?
So about the
Advice to
younger children.
younger geodesists, like around my age and younger than me, for example. So,
Yeah, for younger, I think in general, people should be, people should be curious. They should not should not fear challenges. Should select fields. It must not be cheerleaders. They should select fields where they have fun, where they are motivated, where they have the right spirit. And I think you should not be aware, or you should be not fear that, for example, if you should learn relativity or quantum technology, you will do it at a certain level, and then you can make it. But not everybody is good in mathematics or physics, but there are different fields where you can well work in, and then maybe at a later level come some interdisciplinary collaboration. So we have also project with social sciences, with all the geosciences, so beyond physics, and there's a good context. So pupils should be curious and then do where they have fun, and then they will be successful. I think yes, you should not only stick into your field, but geodesy is very broad. So in our in Germany, it even covers land management, many fields, and so and also it is that broad. You should still keep contact to other disciplines, electrical engineering, civil engineering, geosciences, in my case, physicists, mathematicians. So you should look outside your field, because we have many connections to many of the other fields, and so you should just use it. You may not know it immediately, but you should talk to people, and then you can come into contact, and then can find new and good research ideas.
Yes, wonderful. You mean that we should work more interdisciplinary,
Yeah, sure.
multidisciplinary work. So, oh, then wonderful. Yes, yes, I do agree. I very much like this. Thank you very much, Professor, for your time.
Yeah,
Thank
thank
you very
you.
much. Thank you
That's
very
really
much.
great.
Yeah, bye bye.
Bye bye.